Okay, this is a short lecture on section 1.2, the classification of matter. We're going to start with the simplest substances or the simplest materials that we can talk about. So we're talking about matter now. The simplest components of matter are what are called substances. Sometimes people will put in, I'll put it in parentheses, pure, a pure substance. For example, cocaine is a substance. Caffeine is a substance. These are specific chemical materials that have a particular set of chemical and physical properties. Table salt is different from cocaine. They may look similar. Baking soda and cocaine might look very similar, but they're different substances. They have different chemical reactivities and some different physical properties. So, substances are made up of either elements. Elements are the simplest substances that we can have. So they are made up of essentially materials that cannot be broken down chemically. Into simpler substances. Okay? So an element cannot be broken down into something simpler. So an example of that would be hydrogen. Hydrogen cannot be broken down into, let's say, johnsonium and woodonium. Hydrogen is as simple as it can get from a chemical perspective. Now, compounds, on the other hand, are what we would say are combinations of elements in a fixed ratio. For example, water is H2O. The substance H2O has 2 hydrogen atoms for every 1 oxygen atom. That is a particular material with a set of properties, chemical and physical. On the other hand, there's another substance called hydrogen peroxide, H2O2. H2O2 has hydrogen and oxygen, but it's a different material. It's a different substance than water. It has different chemical properties and it has different physical properties. So the fixed ratio that we're talking about, what we mean is that if it's water, it's 2 hydrogens for every oxygen. If it's hydrogen peroxide, it's 2 hydrogens for every 2 oxygens. Okay? Relatively simple there. Now, it's not unusual or not atypical for us to look at issues involving states of matter. So this figure here shows 3 states of matter for the same material. It's not necessarily clear what this is, but it's some sort of atomic material, an element most likely. Each of those little balls is identical, so it's an element. What's shown here is the physical shape and size of that material, of that substance, as a solid on the left, a liquid in the middle, and a gas on the right. Notice that for the gas, how much space it takes up. It takes up the entire container. Gases will acquire the same shape as its container and the same size, the entire volume. That's what gases do. Liquids, on the other hand, will take on the shape of the container, but will not occupy the entire volume. Solids have fixed shapes and fixed volumes, meaning that the solid will take on a volume of its own that does not depend on the size of the container. So the volume is not affected by the container. And the shape is not affected by the container as well. So solid there on the left. Now, a more complicated situation is what we call mixtures. So mixtures are combinations of substances. So in this figure here, there's 2 figures shown, one with a magnet before and after there's a separation taking place. Notice what the magnet is doing. It's pulling iron filings out of the sand. This is a mixture. A mixture has two or more substances. So the two substances, this one would actually have many more than two, but let's just for simplicity's sake say there's two substances here. There's iron, which is an element, and there's sand, which is silicon dioxide, which is a compound. So the two substances are being separated using a physical property called magnetism. So mixtures are combinations of substances, and those substances can be separated by physical means: boiling, freezing, magnetism, lasers, for example. Different physical filtration would be a good example in chemistry. Those are how you separate mixtures. Compounds cannot be simplified by using physical means. So for example, if we take hydrogen peroxide or water, these ones up here, you can't separate the hydrogen and the oxygen via physical means. You have to use a chemical means. So compounds can be broken down into their elements, but only through chemical means. Mixtures can be broken down into their components using physical means. Okay? So here's a little flow chart of how we could categorize matter. So all of the matter, there are mixtures on the left. Okay, so think of the sand with the iron filings. That's a mixture. And we could think of mixtures as having two possibilities. One is homogeneous, and the other is heterogeneous. So homogeneous is where they're mixed so well you cannot see that they are a mixture. So for example, seawater. Can you see the salt that's in seawater? You can't, right? It's so well mixed that you can't tell the difference, that there's salt and there's water in there. So we would call that a homogeneous mixture. The thing about a homogeneous mixture is that if you take a little bit, just a small sample of it, it's going to be the same no matter where you sample it. Now, the other type of mixture is called a heterogeneous mixture. That's the one that we see here in this picture. You can see the iron filings. They're separated already, right? They're the black ones. The black pieces are the iron filings, and then the brown or the gray ones are the sand pieces. So that's called a heterogeneous mixture because you can see them physically as being separate materials, separate substances. Now mixtures, as I said, can be separated using physical methods such as boiling, freezing, filtration, magnetism, those sorts of methods. Once you do that, now you have what are called substances, right? Substances are either compounds, so compounds are mixtures of elements or combinations of elements in a fixed ratio. Water is H2O. Hydrogen peroxide is H2O2. Those are compounds. If you use chemical methods, you can break down compounds into elements. So let me show you real quick here. You can take hydrogen peroxide and you can use chemical methods to break it down into hydrogen and oxygen. So that would be a chemical process. Okay? So by definition, taking a compound and converting it into elements, right? These are elements. And then this is a compound. By definition, that would be a chemical process. Okay?